Okay, it's switching on and off, doesn't matter. I know what I'm talking about. So yes, you're absolutely right. Deep learning is a really, really heavy hammer. And actually, I love deep learning. You will see at the end of the slides why I'm actually proposing to always use it, but that's up for discussion. Today, we'll talk about a project which we did at the Deutsche Bahn together with DB Cargo, and it was funded by the EBA, the Eisenbahnbundesamt. So it was very successful. It was a 2-year project, actually, where we started off with really starting from digitization, pen and paper, up to later one of the biggest digitization projects in the Deutsche Bahn. Really, really interesting. And if we have our screen. So, anyways, it's about introduction. First slide would be introduction. So, Christopher, you are just handling the slides, so I'll just introduce you. So Christopher Wetekamp, he's a data scientist at our company, and he was working on the topic. He came a bit later to the project, but still he was actually one of the main figures there because I was a technical lead and I was so happy to have him because he was the data firefighter whenever a deadline coming up. Actually, he made sure that we reached that deadline. So thanks a lot, Christopher. Okay, so I can just talk a bit about the project in general. How did it start out? So the thing is, before we started off, the Deutsche Bahn, or specifically Deutsche Bahn Cargo, they actually did not know where their wagons are. It was just really pen and paper, and was stories which are really happening. It was crazy for me, to be honest. They would take up the telephone and just ask around. So because they had orders, and the order should go to Rapperswil, for example, the wagon should go here, and they had actually no clue where the wagon were at the point. So they'd call, take up the telephone, like, hey, Rüdiger, at, I don't know, Maschen, did the wagon pass yet? Yes, so 1, 2, 3, 4, 7. No, it didn't. Okay, I'll call later. That was actually happening, and people would spend actually hours of their day just doing that. Somebody told me their work was actually to track food trains, like to track that the cooling chain of food is not disrupted. But what she actually was doing, she was just calling stations to see where the wagons actually are, because a customer wanted to know where's my wagon, when is it coming, right? So, going to the next slide, you will see that we actually had a solution. Well, we came up with a solution, and the solution was to actually equip every wagon with telemetric boxes, right? It sounds quite simple. Interesting, yeah, okay, we're starting off here. I didn't talk about the company, it doesn't matter. I'll put that into later. So the point is exact. So it might sound easy, right? But we put telemetric boxes to each wagon, and the DB Cargo has 60,000 wagons. So we equipped actually every wagon. It sounds easy. It's not that easy because other companies like Siemens, etc., are involved. A lot of regulation, a lot of stakeholder management. So it seems easy. It's not. Anyways, we are happy that after 1 year, we actually were able to have the 60K wagons equipped, plus a third-party wagons, which is also running around. What we got, our boxes, which translated their signal every 10 minutes. And it was telemetric data, so it's not only GPS, but also accelerometer, density, humidity, anything you want to have. We actually focused mostly on the GPS data because that was interesting for us. It was not super accurate because cost, right? So they took actually the cheapest GPS out there probably. And the point is it was localizable for roughly a meter, but also up to 20 meters. And sometimes we had to switch to GNS or telephone communication, then you had like kilometers actually. So it was not super accurate, so no track pinpointing. But for our case, we just wanted to know where the wagons are, right? It doesn't matter if it's there or there, it matters if it's somewhere around here, right? So also thinking like an engineer, we have to solve it. We don't have to be perfect accurate. And that's just, the whole thing was called codename VAPE. Actually, it's just called VAPE, a value-added business event. That was the whole project name. So whenever you see it, that's what I'm talking about. And going to the next slide. So what did we actually achieve here? So I'm starting with the results. You see on the left, yes, on your left side, you see actually how it looked like before. And it doesn't look that bad, to be honest. That's because of German efficiency, right? So every time a wagon would reach its destination or would start from its destination the other way, the starting point, somebody on the track would put down the number saying, yes, this wagon just left our shunting yard and it's on its way. And then after its shift or whenever you had time, you put it into the system and that would be sent to the DB cargo. And then they would know like, hey, perfect, the wagon is on its way. But you can imagine that can take hours, sometimes even days until the information is reaching the system. On the right side, that was actually after we were finished. And you can see at the beginning it was like 12K manual entries, and afterwards, in one week, afterwards we had around 3.5 million entries per week. And the point is, you can see also the graphical illustration here. Of course, the effort beforehand was tremendous, right? People have something to do. They don't want to put data in. These numbers, long numbers, they have to write them down. There's a lot of error proneness in there. And especially the actuality very low, to be honest. And that we could switch around really, really well. But also you see something else. Because if you look closely, it's only Germany here. And to be honest, whenever a wagon actually moved past a border, that was actually complete zero information. They had no clue where the wagons were, and were just hoping that the wagon would come back at some point. Maybe, right? And that was actually happening. So, because there was no information exchange between France, Italy, Poland, whatsoever. So inside Germany, it was working okay. To be honest, it's not working okay because the Deutsche Bahn is crazy in deficits, and that can be one of the reasons. But anyways, it worked somehow. Yeah, so we could change that. And if you go to the next slide, the question is, how did we actually start? How did we do that? First of all, we created so-called geofences around every single station in Europe. Here you see Germany, and in Germany alone we have around 7,000 geofences. That means we have roughly 7,000 stations, which are important. Actually, it's even the unimportant ones got one. So everyone got one, and we did that with Voronoi algorithms. I want to say diagrams. That would be a Voronoi diagram. While we did it with the algorithm, meaning it's kind of random. We of course didn't go through every station and draw it, but it was done automatically, and that will be a problem for later when Chris was talking about it. Just to see how we did further, so we actually didn't only do Germany, we also did Europe, and that will be roughly 50K geofences. And as you can see, I mean, for example, Sweden up there, they just don't have so much geofences because they don't have so much stations. That's it. There's a lot of wood up there. There's a lot of wood transport actually also. I learned that. Quite interesting. So that was the starting point, drawing the geofences. And then, I mean, it's quite simple, to be honest, right? And then you say, okay, now I have a GPS signal, and I have my geofence, which is also just GPS coordinates, more or less, or geo-coordinates. And what I do is I just identify when does a wagon enter a certain geofence and when does it exit a certain geofence. And then you have additional parameters like speed and if it's standing or not standing, for how long it's standing, etc. And with those information, you can actually create this business added value events. No, other way around. Anyway, so that worked actually quite well, and you can see the numbers up there. So I said we had 50K geofences, and just like departure, pass-through, arrival, border crossings, we have like 13.5 million per month. And that alone is not actually order relevant on the left side, but it's relevant for tracking, just to know where are my trains, are there any problems. Also estimating the time of arrival in the future, that is all based on this parts. While on the right side, you see order activation and completion. That is actually quite important because you have to activate an order that somebody knows where it's going to. Then if the wagon is arriving at its destination, you want to close the order because otherwise no new order can be put on the wagon. And huge chaos can ensure. We saw huge chaos if we don't do that correctly. So we are very happy that it worked out really, really well. In the end, we had like this 13.6 million per month, and the thing is still growing. More and more are coming. Really successful. But the devil is, of course, in the details, because you would say, like, you took 2 years for that. I mean, it's GPS and geofence. Come on. Chris will talk a bit about one of the many problems we faced and how we tried to solve it.
Yeah, thank you. So Jan already mentioned that it's really important to match the order number correctly to the wagon, because otherwise we just simply know where a wagon is located. So in case we're missing one, we could find it, but that's not overall interesting for the customer at all. And so we need to improve our algorithms to create these geofences, or at least for the activations and completions, we need to more precisely. And we brought some examples with that, which you can see here. On the left one, for example, we have a big one created, but you can directly see on the map there are single shunting yards. And for example, we could be way more precise if we only use these exact shunting yards where something is happening in the end. And of course, other problems occur because at some point we need to calculate which area belongs to which stations. And there we are looking via tracks, which station is the nearest, because it's the easiest algorithm at that point. But as you can see in the middle, this can lead to the fact that there are some strange shaped geofences. And of course, you can now think if you want to deliver something to the utmost point, maybe it's somewhere else as well, or for the bottom station that it's up there still. So we need to be more precise here. And the first idea was to call the experts from the on-site factories, for example, but more than often they weren't correct. And you see, for example, the example at the bottom right corner, where we can see the expert claimed us this exact location. And we were in a meeting with him for 1 hour, and he was like, yeah, 100% sure. We went everywhere, and he even explained what is happening at that location. But in the end, when we took a look at our GPS data, we saw there's never a single wagon really standing at that point. They are only passing by at that point. And so we said, this is not scalable. First of all, because it needs to be entered manually, and secondly, because we always need to ensure the data quality on that side, because as Jan already mentioned, if we are not completing the order, the wagon is going to travel further with the old order number and will only be completed if by coincidence it's going to the exact old destination again and being closed, or if somebody is closing it manually. So in Germany, that's not such a big problem. But as soon as we're talking about, for example, Switzerland, we had it often that trains were going to Zurich and then to Bern. And then there was a problem that the trains were tingling around in Switzerland and still had the first order, which went to Zurich. And so we need to find a solution for that again, and hopefully some automated solution. And for that, we started to think about, okay, we have the GPS information available, and unlike the experts, they can really tell us where the wagons are actually located. So why shouldn't we use that to perform our cluster analysis at that point? And as you can directly see at the left image, we see there is a huge point cloud, which we can use. And even every one of us can directly see there are specific areas where the wagons accumulate and where something is happening. And so we used here a multi-layer clustering approach to really identify these clusters. And the real results of that one, you can see in the middle, where we have those nicely colored dots, where all the noises are a little bit removed. And we can see there are different areas which are really important for us. But in the end, what is going to happen now? Because we need to continue. And as you can directly imagine, the wagons are not only standing or parking at the destination point, but also in buffer zones and in front of switches or halt signals where they need to stand and wait. And if you're looking at the middle image, for example, you can see it. There is this orange cloud, which is in front of a factory location. Yeah, you see the gray cloud, which is part of a buffer zone. And then, for example, the red one, where we later on, and directly can see it here, we have a factory building where trails and tracks are going inside. So most probably this is going to be our location. And of course, we were now thinking, we can clearly see here the railway infrastructure elements visible. Like we see a warehouse with tracks, we see like a buffer yard where a lot of tracks are coming together. And we were thinking, there needs to be a solution to do that. And of course, as data scientists, we always think about the nice and fancy AI solutions and came up with some ideas. And we're like, okay, let's test it out. We can, for example, go for instance segmentation and say, we want to detect the single instances like warehouses or tracks and use these masks, which are created by the instance segmentation, to have like an intersection with the clusters we found, so we can kind of classify all of this information. Another approach could be to go for the railway network in the end, because if, like we saw it in the image here in the middle and on the previous slide, there is a specific structure for all of these networks, because trains need to be connected. They cannot stop, and at some other point they can continue. They always need to be connected via switches. And so we have like a typical graph problem here, where we have nodes and edges which are connected in a specific way. And of course, we could use this information as well for identifying specific areas here. And last but not least, of course, the object detection, where we had the idea maybe we can even directly detect broader key structures at all, where we have like entrails and buildings together in one point. But all of these methods have in common that we need data and labels. In our case, it was quite easy to get the gate data because, first of all, we had all of those cluster information, so we knew where roughly the trains are standing. So we use this to eliminate the rest of the world, kind of, so that we are focusing on this specific area. And then we simply used the OSM data. Maybe you're familiar with that, OpenStreetMap. And this is an open source project, which is like, I think, the biggest open source GIS database. So in case you're searching for any geolocation information, you can go to there and extract your information there. And it's also like the source for a lot of open source maps. So most probably all of you have used it at some point in the background. And even to say, even Apple uses part of the OpenStreetMap to enrich their own data. And everybody can extend and update this. So for example, you could go on the map, log in and say like, okay, this building is looking a little bit different. I want to adapt it. And everything is versionized and it's an open source community. It's a really cool project. But coming back to the topic here. When we saw this, we directly had our plan in mind. We're going to split up, we're going to label, and then we're going to test and evaluate all of those models. But in the end, the reality is often a little bit different, and instead of a fancy AI solution, we ended up with a well-founded feature-based GIS solution. And what happened here, I will guide you through that process shortly, because the clustering, it was working fine. We are getting all of our nice clusters. And then we set together labeling. And as you all know, you're sitting there, it takes a lot of time, a lot of discussions, because especially if you're going to the instance segmentation, how fine granular do we want to be? At which point, for example, do we say, oh, we have a specific structure with a railway and a building, then there's just like a meter in between. And at some point I was like, I'm not so keen into labeling, and there must be a better way. And there is a better way. And I came up with the idea, we already have the OpenStreetMap data available. So for example, I can grab the coordinates as a line string of a track and use it to create a mask automatically for our instance segmentation. And we started to go further with that. For example, we added heuristics to it because I was interested in the end rail tracks, because if you can probably think of, if there is a track ending, there's probably going to happen something at that point. And it worked quite well. We said like, okay, we're just taking the last part of the track, going back to the last switch, and that is our end track. And with that, we created some set of features in the end and used it in the beginning for our labeling process. And you can see some of these images in the middle. It was at the beginning phase where we started with it. For example, we even segmented channels and rivers at that point, because there are a lot of train stations in harbors, which can be important as well. And while we were looking at this, we were thinking, stop, what are we doing here? Because in the end, what is our overall goal? We want to detect key infrastructure for the railway. So why do we need to take the OpenStreetMap data, which consists of graph data, but in the end, it's vector data if we're going to plot it. So in the image processing, for example, we are taking this vector data, we are creating a map, and then afterwards, we are using an image process and using vector data again. So why should we go this extra step? We can directly use the OpenStreetMap data. And in the end, we were already capable of identifying all the key features we are interested in. And so we went with that version and said, give it a try. And we extended even more features so that we had like well-defined features. I think in total it were 20. We had, for example, how many switches are in the area of the cluster, and even more. And in the end, we then went with a tree learner, with an XGBoost model to predict these clusters. And now you're probably thinking, how are you going to evaluate all of that in the end? And for that, we went a little bit more with the engineering approach at that side, because the evaluation needs to fit the problem and should be tailored to it. And if we're remembering, our task is to improve the activations and completions. So this should be our metric number one, which we need to follow in the end to be successful with the project. And so our task was to check and set up a monitoring where we're checking for each delivery point if the wagons, which should go to that point, are really reaching the destination and are getting a completion message. And with that approach, we can use our full history of data sets to test it all against our clusters, identify special cases, and see how it is working. And the main problem here, which we are, as a data scientist, feel a little bit uncomfortable with, is in the end, we cannot say for each exact cluster if it's a delivery point or not. But overall, it's important that we are saying it's correct for the area, for the delivery point we are talking about. And that is because there is often no real ground truth in the problem, because the devil is in the detail. And sometimes people want to get deliveries to specific areas, sometimes more like in the range. There's a lot of stuff happening manually. So for example, a train is going to a station and then the people on site know where this wagon needs to go. Nobody writes that information down at some point. And so we are fighting here that typical problem with get your correct labels. And overall, it worked really, really good because we were able to improve the activations and completions in such a way that in the end we were quite sure that it's going to work very good. And we rolled it out for complete Europe. And so far it's working. And further iterations are currently in progress. So you can probably think of there are many, many ideas how one can even improve these algorithms. But this was like the first approach we went with. And now I'm handing over to Jan.
Yeah, so there are actually a few learnings I had with that. That is like a bold statement. Some people will lynch me maybe. So first I'll maybe take another one. It was quite interesting for me to see if afterwards, because afterwards you're always a bit more, you know the stuff you did. And it's interesting because we looked so many times at maps of tracks and trains and stations. And so the most obvious thing was to think like, of course, we do some image processing, right? I mean, because I can see that this is a shunting yard. I can see that this is a facility where a train would be ending, right? So that was the first idea. While in the end, we already worked beforehand with all this graph information. It was just sitting in front of us, all this information, and we didn't use it. And just by, hey, let's help our vision tasks or cool deep learning stuff, let's have that with this graph information. That was actually, then we suddenly noticed, like, wait a second, we already did it, right? And that was quite interesting. That, of course, as a human, you first try to do that what you know best. And we have best pattern recognition. Images is just one thing humans can do absolutely great. So I think that was normal that you did it this way, and this has happened. But there's another point. So as I said, I know especially in the software development community and generally developers, they look at especially the word deep learning quite critically. I mean, my brother-in-law, we have long hours of fighting discussions about AI and this kind of stuff, and he more or less hates it, hi Paul. So, and because he said it's of course overused, right? You have an app, you have deep learning is cool, AI and so on. That's actually true. So that is actually that's a negative purpose, to be honest. But if you do such a project and you see actually the benefit what you're doing, and we saw it while doing it, how much hours of time we actually saved for the people working with this data or with the order management process, for example, we noticed we have to push this idea because it's a huge enterprise, right? A company like the Deutsche Bahn, they have hundreds of really interesting projects or not interesting projects, and you have to shine. And just yesterday, we had a nice discussion actually about it. IT in general, programming is always kind of seen a bit negative because it's always about, hey, it still has some bugs, it still has to be maintained. Oh, the software is still not working. So it's very few times that people say, oh, this is working really great. So you actually, as developer, has to push the things people which are not programming, that they understand it. And deep learning is one thing they do understand. So if you can make your department head or whatever happy by saying, hey, we use the latest shit, your problem, your solution, even maybe if you could have done it also with classic machine learning or so, will get actually the attention it deserves. And I don't say you make an app and do deep learning, but if you think your solution is great, this is actually a tool to make it more visible. So thanks a lot.
All right. Thanks a lot.
You're welcome.
I guess there are a lot of questions because we have quite some time for questions. So, do I see any raised hands? Here. The microphone is coming.
Thank you. It was very interesting. But one thing that maybe due to the technical defect maybe was glossed over a bit. I didn't really understand the actual problem. So what is an order and what happens to the cars? Do they get decoupled? And like, what is the problem exactly there?
Yeah, very good point. So where to start? So yeah, so you're a customer and you will say, okay, I want to have a container. I want some goods delivered from, I don't know, Poland to Rapperswil. So you will just set up an order, and this is the order the wagon has. So the order will be put on the wagon as the goods are put on the wagon, and in this order is all the information, where it should go, when it should go, who you are, if it's paid or not, all this information. And the point is, yes, in Germany it's slightly different than in other countries, because in Germany we have the so-called Einzelwagenverkehr, which is single wagon traffic. Because the idea is from the politics that say we want to have goods on tracks. We don't want to use trucks, etc. We want to use a railway system. But therefore, you have to give small customers the chance to also order just one singular wagon, right? While, for example, in France or Italy, you can only order a whole train of 20 or more wagons. So tracking that is much more easy because you don't have to decouple, etc. But in Germany, it's actually like this. If you would go a wagon from Poland, it will go probably to Maschen, I guess. Huge shunting yard. Actually, the second picture is from Maschen, so maybe you can go up. A huge shunting yard where actually every wagon, every train is decoupled, rearranged, coupled again. And this is actually at the time is done by hand. Every wagon, that's a huge iron chain, has to be decoupled, pushed down a hill, and coupled again. And first of all, in this process, a lot of things can happen. I mean, somebody said like, oh, whatever, I put the wagon just on this train, doesn't matter, it goes the same direction, I don't care. So suddenly you don't, I mean, there's a process of this order, how it should have been, but it's never happening. As soon as the order is out, the order is already faulty. You cannot trust the order. That was one, actually, the first point we noticed. First question, like, oh, we have this data, we have this order data. Can we trust it? No. So that was, okay, great. So we have huge amount of data which we cannot use because we have no clue if it's true or not.
And maybe you should jump in here quickly in regards of the order number. So the wagon, one time it's going with you as a customer, next time with Jan. And so we need to have information that this wagon is currently working for you and where it is located. Because if you think, for example, of wagon tracking, we want to provide you with the information where the wagon is located. And if we are not completing the order, then the wagon will write for Jan, but you will still receive the information because in the systems, everybody is thinking your order is still active. And in the past, they did a lot with paper and pen and phones. So there are metal boxes, you can still see them on the trains where a paper was put in, where it's written, it's going from there to there with all the information Jan talked about. And so the people take this paper and then they call, for example, in the center and say like, this wagon is here and we can close it. And then the next order can be activated. And for that, we need some sort of automation because you can think of like, that can break a lot of stuff. And especially outside of Germany, nobody is giving us the information.
Yes, it's just also a business problem, right? Losing your wagon, you have just a huge amount of assets you don't use properly and mixing up of orders. And yeah, just imagine anything, it happens. Yeah.
In the back is one other question.
Thank you for your talk. I'm a member here of Swiss Python Summit, but also a volunteer for OpenStreetMap.
Nice.
Thank you.
We're happy to hear that our community was able to help you and Deutsche Bahn solve a problem. So we're wondering, are there any plans to give back to the community in some way?
So I myself really looked in and worked with it. And in the end, I tried to implement it a little bit more at the Deutsche Bahn. So I did like 2 intro sessions with the people, but there's until now still like everywhere the thing was open source. They are saying it's not our source, who's going to maintain it. And I was always telling them, but you're not doing it better, you're doing it worse. You have systems here and data which is not updated for 10 years. And with OSM, you have people out there who are seeing something is not in place, something has changed. We should start working together with them. And I personally try to recommend the companies or the 2 times I worked with OFM in projects, that we should try to get the information which we have available on the platform as well.
Okay, yeah, thank you, therefore, for your endorsement. So what you could do, or what all of the participants here could do, is to like publish data. That's actually, if you have some geospatial data or other data, doesn't need to be geospatial data of whatever content, whatever format, what you always could do is to take this data and publish it, make sure to give it a license. The easiest one is CC0, meaning you can do with this data whatever you like, and make it known to, for example, to OpenStreetMap, and people will have a look, maybe not, but if it's openly licensed, it's a good way to contribute back, and it's practically no effort for you or your company. It's just important that we have a clear understanding of the license.
And another question over there. Yeah.
Hi, super interesting talk. I was really impressed that you said it took, 2 years for this whole thing? That's really the case?
Actually, it took even longer, exactly, yeah.
But there are other problems as well. So like the whole infrastructure, everything need to be set up, the complete data engineering team. So there was a lot of work done in parallel and also stacked, so like in general with the data. And data is fed from many different sources together. So it was a huge task to see which information is reliable, how can we join this information, because there are 3 different systems which are tracking order numbers. And now you need to get like a common sense, like what is really happening. And sometimes the truth is even a 4th option.
Yeah, so I was going to ask, like, what kind of percentage of this work was engineering versus like just politics? And then also, if you could, like really quickly, what kind of infrastructure are you running all of this on?
So in the end, we used a Spark cluster for most of the computations. Our own algorithms, we simply had like a Python scripts in place, because first we thought like, oh, we really need to think about parallelization and all of the stuff. But in the end, it was sufficient to do it like normally it would just run for like 2 hours. And we said it's okay because we have more important work to do at that point, because other important topics were during these years, for example, Fremdwagennutzung, like if people are not using the wagons correctly, like saying you're going to have something delivered from Hamburg to Switzerland, and in the old system it would be possible that you're delivering weapons from Switzerland to Russia, and nobody would have noticed, because in the end, when it's back in Germany, we have it back on our radar. And now with the telemetry boxes and all of the orders, we can track something like that as well. And so a lot of development were in other side projects as well to really benefit from the GPS data in combination with the order data.
Cool, thanks.
All right, there's another question on the left side.
Thank you for your talk, and I work also with OpenStreetMap data and started to contribute myself. And I wanted to ask 2 questions. How much problem did you have with the really open text tag system they have, so that the same thing can be mapped in different ways? And the other question is that the data is not equally good mapped in different locations. Maybe you have a really excited mapper who maps every switch, and in other areas you're happy to have the track there.
Yeah, so on our side, it wasn't so important, because overall, for us, it's okay if it's roughly there. And in the end, we are not only working with the tracks, but we have our GPS cloud as well. So we see if something is off track, and we are using everything in the area. We were also thinking about like an improvement in cleaning of GPS data by mapping to the nearest track and stuff like that, if it's in the nothing. But we had it, for example, for one customer at a station. There were, for example, no maps, no yards mapped. And later on, I did it on my own because I saw it on the satellite images. And it's in the end the manual work you need to do, and it's an open source project. And if it's like at some small town in the backyard of a company, nobody is passing by, Because maybe just to enter that for OSM, you can simply download an app or on the computer or on the phone and can map while you're going. What you see, you can tag it, you can add information, metadata information like how many levels does this building have and stuff like that. So it's really powerful. But for us, it was okay how the data is. And we are, of course, working in Europe where the data is quite good.
Interesting point. So because it goes back to politics, maybe you heard of that as well. So as when we presented that solution or the idea to do this, there was exactly kind of this question, like, yeah, but how could you do that? Because maybe in a remote area, you won't have that information. And like, okay, what information do you have now? Oh, 0. Okay, interesting. So it's mostly better than what you had before, but people don't see that. They see it. If you propose something, it's like, well, but that's not 100%. It's like, yes, but it's better. So it's always to remind people that the system doesn't have to be 0 to 100, but it's fine to do a gradual improvement. But maybe before we close down, I want to have to say one thing, because we painted the DB cargo now in a quite bad picture, to be honest. And we have to see it a bit in a way, they're kind of the lost child, right? So when an ICE train comes, the cargo has to wait, right? When the track breaks down, the cargo has to wait. So they're the least ones to get any improvements, etc. And they worked actually quite well with what they had before. And they're innovative because they went this direction, said, we have to do something. So we have to equip the wagons with GPS data. They just did it. So even if it sounded quite negative, they're putting a lot of effort into overcoming these problems. So even a big shout out to the DB cargo that they're doing that. So yeah, in the end, thanks for making a fun talk, shitting on them to make that possible. Yeah.
Yes. This is a good entrance for the break that is now. So yeah, thanks a lot. It was very interesting and entertaining as well.
Yeah, thanks a lot.
So yeah, enjoy your break.